Hi, and welcome to Dragon Mathematics. I'm Dragon, and this is the mathematics. So, this is going to be the pre-calculus series, and this first video here is going to cover functions. So, functions. Here's what we're going to do in this video. We're going to say, what is a function? We're going to say function notation, how to write them. We're going to talk about what a domain and a range of a function is or are. We will learn about the vertical line test. We'll capitalize it, make it seem official. And then we'll just look at some functions at the end, but you'll probably see some along the way. So, what is a function? Well, a nice analogy you can use is you can think of a function like a machine or a rule, I suppose. I like the machine analogy because the machine analogy says, okay, you have this machine here. Something is going to come into the machine, and then out comes something else, which will be our y. We call the x the input, a y an output. So if you have a machine that whenever you put in, right, a duck, am I going to be able to draw a rubber duck? Sure. If you have a machine and what the machine does, its function, right? Its function is to here, I'll write it down here. When a duck goes in, a car comes out. Okay, so the duck goes in, guess what's going to come out? It's going to be this nice vehicle right here. Totally normal looking car. Okay, there's the exhaust, headlights. So this is a function. A duck goes in, a car comes out. You can think of it like a rule when it's like an if-then statement. If X, if a certain X, then this Y. Right, so you can think of it like a machine, you can think of it like a rule. Again, you can see how all of those things are analogous to the word function. Another decent analogy, I suppose, is like a vending machine. If you put money into the vending machine, that's your input. You press the button and you get a specific snack out, right? You don't get a random snack. So money goes into the vending machine. These are all the different snacks that are on here. And then say you input B9, right? Well, then you're going to get out the bag of chips. So when you put the dollar in, that's your input. And when you get the chips out, that's your output. Maybe it's better to think of this code that you give the machine, right? If you tell the machine G3, well, then you get out candy bar. I don't know how to draw a candy bar. It's just a candy bar. And then if you put in A2, you get out a soda, right? So whenever the function is given this input, you get out this specific output. If you put in G3, you don't just get either chips or candy or soda, you only get candy. Okay, so notation. Let's call it function notation. So functions in math can be labeled as you'll see all sorts of variables, f, g, h, and sometimes we don't write it, but this f actually secretly means this if just f by itself is ever written. And same goes for g, and same goes for h. So the way to say this is f of x, g of x, and h of x. And so what does that mean? Well, this f is the function, this x is the input variable. So if you have f of x equals 2x, right? This function on the left side of the equal sign is defined here as 2 times x. So that means for this function, f of x equals 2x, f of 3 equals 2 times 3, f of 7 equals 2 times 7, right? It's saying function, whatever the input variable is, this is how you should expect the function to work. So for this function, the y you get out will be equal to 2 times the x that you put in. And same goes for in a single problem, if you see f and g, then you can reliably expect that these functions are different. Maybe they're not, but say f of x is still 2x and g of x is 3x. Well, now we can write this as well. f of 2 will equal 2 times 2. F of 3 is 2 times 3. And g of 2 is, let's do a different number because it's going to get a little confusing. G of 4 equals 3 times 4. G of, say, 8 will be 3 times 8, right? And again, these, I know it's a lot of letters right now. There's F, G, I wrote an H, now I'm writing X and Y, but it's just a standardized notation, formalized thing that, F, G, H, Q, you could have a function Z, that's fine. This is a function f of x. For our purposes, this is a function g of x. This is a function h of x. Okay, and so all of this is with respect to our x and y graph, our grid here. So when I'm saying all this, here, I'll get this off the screen here. So when I'm saying this, what I mean is, let's go back to f of x equaling 2x. Remember, this is the same as writing this. You can say y equals 2x. That's also true for this function. And f, the function, is equal to 2 of x. All this is, this last one, all this is this f of x, but you might see it this way if someone's being lazy or whatever reason. So for this function f of x, 2x, let's say this is 1, 2, 3, 4, 5, and this is 1, 2, 3, 4. I might add some negative numbers, we'll see. If this is the function that we're interested in, that we're looking at on this plot or this graph or this grid, okay, then if we say, okay, well, x is 1, okay, when x is 1, comma, y is 2 times 1, 2 times the x, so y equals 2. So when x is 1, we go over here to the x-axis, we look at 1. When x is 1, we go over here to the x-axis, and then we come up to the 2 on the y-axis, right? And where these meet, we have a point. And this point is 1, comma 2. So x, y are in there. And it might help if I use the grid. Okay, so when x is 1, y is 2 times 1, which is 2. And then we can also just quickly, I'll say, when x is 2, y is, and I do the math, 2 times 2, because it's 2 times the x, so y is 4 there. And that's going to be off my grid, so okay, so when x is 2, y is 4. Then we can even plot some in the negative direction, right? Let's say when x is -1, y is, well, it's y is equal to 2 times -1, which is -2. So I'll go here to -2, and then the -1 on the x-axis, we go down to -2. There's our point. And so we're starting to get a picture of this function right here. This line is the function f of x equals 2x. So here's a point, 1, 2. Here's a point, 2, 4. Here's a point down here, -1, -2. Okay, so that's a very simple function. And next we'll talk about domain and range of a function. So the domain, the technical definition of domain, is the set of all possible, this is important, input values, which are x values, for which the function is defined. Okay, so that's just to say that for any given function, there is a set of x's or inputs that the function can take, and there's a set of outputs or y values that you will get out of that function. If you have the function f of x equals 1 over x, then x equals 0 is not in the domain, because when you graph that function, you can actually see on the graph that there is no, right? There is no part of the function at x equals 0. This is not f of x equals 1 over x, by the way, but I mean, I suppose we could use 1 over x. So 1 over x looks something like this, right? It's a weird function to think about, but as you'll see, when x equals 0, right here, this goes on to infinity, this goes here to infinity, this goes to infinity, and asymptotes. There's no value on the function. The function doesn't exist there. Which is, when you're new to this stuff, it is an interesting thing that you may be intrigued by, and you might find it weird, and you might not want to accept it, but it makes it easier to get through your courses if you just accept that. And then later on, once you're good at this stuff, you can explore, and you will actually be taught to explore in higher level classes why that is, and what exceptions and what weird cases there are, blah blah blah. So don't get caught up on this though. The only reason I brought it up is to show why we even care about the idea of a domain, right? So f of x equals 1 over x, so this is a function. For this function, the domain is x does not equal 0, is one way to write it. So any x value besides 0, x is allowed to equal 0.001, x is allowed to equal negative 17, right? All the way to infinity in both directions on your number line. On your x-axis, you can put any x into that function except 0. We're not allowed to put 0 into the function. Right, another quick example of that is if you have the function f of x equals the square root of x, right? The domain of this function is going to be x is greater than or equal to 0. And that means on your number line, you have 0, right? Well, you can use 1, 2, 3. You can use any of these decimals in here, 0 0.5, 1.5. Those can all be the input to your machine, right? But anything here is not allowed, right? You can't have a negative number, at least when we're talking about real numbers, going into this function, because if we put a negative number in, so f of x equals square root of x, if we put a negative 2 into that function, then f of negative 2 would equal the square root of negative 2, which when we're talking about real numbers doesn't have a solution. I just write it like this. It's a lazy way to say no solution, but so that's a domain. That's technical definition, an example, and you know, domain is the allowed x's of a function. Okay? The domain of this beautiful thing called a parabola, which everybody loves, right? The domain, well, this is my x-axis. This arrow means that this goes on to infinity. And so x values go from left to right on this graph. And so this dot, dot, dot will go left to infinity, negative infinity, I should say. And dot, dot, dot will go right to positive infinity. So the domain of this, you can say all real numbers, or another way to say that is this notation, negative infinity to positive infinity. So the domain of x squared is all real numbers. Remember that this parentheses means not including the things in it. So if you have a domain like this with brackets, say it's what, 0 to 100, right? This means the domain includes 0 and it includes 100. And then obviously it includes everything in between. So 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way to 99, all includes 100 plus all the decimals. But if you have this domain, this means excludes 0 and excludes 100. So in this case, it would be 1, 2, 3, 4, 5, 6, 7, 8, and then 97, 98, 99. and also the decimals, so 0.00001 and 99.99999 are all included, but 0 and 100 are not included. So remember that. The reason I say that is because if you're ever writing a domain or any set like this with infinity in it, it will always have parentheses. Because if you think about it intuitively, you can't include infinity because, as everybody knows, it's not a number. And we'll go into that in another video. So I think we covered domain pretty well. Range, you may have guessed, is, what's my technical definition again? Range, if I give the technical definition, will be all possible output values, which are y values, of a function. So basically, what y values do you get out? And I'll go back to our parabola, right? If this is f of x equals x squared, remember the domain was all real numbers or from negative infinity to positive infinity, not including the infinities, right? That was the domain, or the x's that can go into the function. Well, what values can come out of this function as outputs as y values? Well, you can kind of look, right? Just by drawing the graph, which we love to draw graphs. We love to draw in math because it makes everything so much easier. This keeps going to infinity, and there's nothing down here at all. There's nothing. So the range of this function is 0 to positive infinity, including 0, because there is a 0 in the function. And then we just put a parentheses for positive infinity because reasons I just explained. So, right, another way to write this is also y is greater than or equal to 0. All right, so this is what the y's can be. And, oh yeah, also intuitively, you can think since the domain includes all the numbers, all real numbers, well, what happens if you square any real number? You should know, let's square 2 here. 2 squared is going to be 4. So 4 is up here, 1, 2, 3, 4. This should be 4 on my graph if it was accurate. And then what if you do negative 2? Well, negative 2 squared is also 4. So any number on this x-axis that you square, remember our function is x squared, is going to result in a positive number. So that's why the graph is only up here in the positive area. And that's also why there's only positive numbers in the range, or the set of outputs, the set of possible y values of the function. And one more good example would be, what is the range of y equals 3? That's an interesting one. Do you know how y equals 3 looks? It's 1, 2, 3, so there's 3. Y equals 3 looks like this. It's just a line, a horizontal line, at y equals 3. So it goes off into both directions infinitely. That means its domain would include a bunch of x's, all of the reals. And the range is just y equals 3, right? Because you're only ever going to get 3 out. The output is 3 every time you put in any x. So domain, possible x's to go into a function, and range, possible y's to come out of a function. Good? Good. So there's a thing called the vertical line test. And what the vertical line test says is, if you're looking at a function, then certainly drawing a vertical line anywhere, which means parallel to the y-axis, just straight up and down, will only touch the graph one time. So if you have this function, or sorry, I should say if you have this curve, let's test to see if it's a function. So this is f of x. Let's try. So I'll draw a vertical line here. Okay, it only touches once. I'll draw a vertical line here. Yep, doesn't touch twice. Vertical line here, vertical line there. It looks like everywhere the graph only crosses each vertical line parallel to the y-axis one time. All right, if you see something like this, you could say, okay, this curve, is it a function? Or I shouldn't even write that. Should I say, function. Let's see. So I'll draw a vertical line here. It passes. So this passed the vertical line test, passed the vertical line test, passes, passes. It keeps passing, but then if I draw a vertical line here, you can see it touches 1, 2, 3 times. That's not a function. No. Not a function. So to put that into words properly, this graph or this curve does not represent a function. And if we go back to our definition, you'll remember, why is this the case? If we have our vending machine and you choose G6 on the little pad, you should only get out, right? Say it's soda. I don't remember which was which now. You should only, if you put in your dollar and you punch in G6, you should only get out a soda. If you punch in G6 and sometimes you get out a soda and then sometimes you get out chips, sometimes you get out candy, that's not a function. And we see here our x-axis. The x-axis is analogous to these codes that we put into the soda machine or the vending machine. So if I put G6 in here at X, right? Say I called this G6 my input and I got out Y, then that a Y that's equal to this, say this is chips and this is candy and this is soda. That's not a function, right? It's not predictable. It can't tell us when we put in an X, we're going to get out a specific Y. So that's why that works. And on the flip side, it is okay to have, in an actual function, it's okay to have, I'll use sine function, which is a little taste of trig, but we're not going to go into trig. We're just going to look at it. It passes the vertical line test, making it a valid function. But you'll see that you can get the same y, right? This is 1. This should go up to here. This is also 1, y equals 1, and this is y equals 1 here. Right, at different x's, you can get y equals 1, so it wouldn't pass a hypothetical horizontal line test. It's just to say that a function only gives 1 y for each x, right? So as long as an x going in only gives a single unique y, it's a function. You can have different x's go in and all give this y, like in sine of x here, y equals 1. That's fine in a function as long as this x1 only gives 1 and x2 only gives 1 and x3 only gives 1. I hope that's clear. I hope I didn't belabor the point or beat it to death. So no matter where you draw the vertical line, it only hits the graph once. This passes the vertical line test, so it's a function. Boom. Okay, so let's look at types of functions. We have linear function. Okay, linear function has this form you may be familiar with, right? Y equals mx plus b. And the reason it's called linear is because it represents a line, a straight line, not a curve. A linear function, f of x equals mx plus b, well, that just means we get an output of y that is equal to this slope of m times the input x plus some value b. So this is the general form of a linear function. So that's the general form. And then this would be a specific function, say 2x plus 1. If we plot it, we're going to see, okay, what's f of 0? Well, that's going to be equal to 2 times 0 plus 1, which is 1. F of 1 is going to be 2 times 1 plus 1, which is 3. F of negative 2, we'll say, just pick something. F of negative 2 will be 2 times negative 2 plus 1, which equals, this will be negative 4 plus 1 will be negative 3. So if I plot these points, this represents the point 0, 1. This represents the point 1, 3. This represents the point negative 2, negative 3, right? When we have that, we can actually draw this. So 0, 1, 1, 3, and negative 2, negative 3. So negative 2, negative 3. So that would be your function f of x equals 2x plus 1. Remember, f of x or y are interchangeable in our circumstance. It's just saying that you get a y output when you input an x. F is just the label for the function that we're talking about. So we can see that this is linear because it's a straight, well, as straight as I could get it to be line. I think my tablet can actually make the line straight. So let's do that. We'll do here to there. Look at that. We like that. Now that's a line. That is accurate of a line as you're gonna get. Okay, so what was this? This is f of x equals 2x plus 1. That's what a linear function looks like, plotted, and its form, the domain and range. Well, the domain, we can look at it. Again, this is gonna go off to infinity, off to infinity. So left and right, it'll go to positive and negative infinity. So the domain is all real numbers, or negative infinity to positive infinity, not including the infinities. And then the range, again, look, it goes up and down, to infinity. Linear function includes, all real numbers, or all values between negative infinity and positive infinity. Another type of function we might be interested in is a quadratic. So the general form for a quadratic function is f of x equals some value a times your x squared term plus some value b times your x term plus some value c by itself. So a, b, and c are constants, and a cannot equal 0, and that's just because if a was 0, then we wouldn't have our squared term, and then it wouldn't be a quadratic. So it is this parabola shape that you've probably seen many times. This is a quadratic function, and an example of a specific quadratic function, let's say f of x equals x squared minus 4, right? For this particular quadratic function, our a is 1, our b is 0, and our c is negative 4, right? So you could also look at it like this. 1 times x squared plus 0 times x plus negative 4, right? So that's why it looks like this, because the 0 times x is just 0. 1 times x squared is just x squared. And I'll do that. And if I want to plot it, I can plot it by saying, okay, x squared, I'll do a set of x's and see what y's I get out. Where x squared equals 0, well then 0 squared is 0, minus 4 will be negative 4. Where x is 1, it'll be 1 squared, which is 1, minus 4, which will be negative 3. 2 squared will be 4, minus 4 will be 0. And do some negatives, negative 1 squared will be 1. 1 minus 4 is negative 3 as well. And negative 2 squared is 4, minus 4 is 0. So how does this look? Well, where x is 0, y is negative 4, 1, 2, 3, 4. Where x is 1, y is negative 3, 1, 2, 3. At 2, it's y is 0, x is negative 1, y is negative 3. Where x is negative 2, y is also 0. So we can see that it's going to look like this. It's this U shape opening upward. It's still horrible. Okay, so then we can label it. This is x squared minus 4 is the quick way to say it, right? But this is f of x equals x squared minus 4, which is a function where it's true that y equals x squared minus 4 at any point on the curve, on the function, on the parabola. Okay, what is the domain of this function? The domain is any x value that can go into the function. So again, this goes off to infinity to the left, this goes off to infinity to the right. So it's negative infinity to positive infinity, all real numbers. And the range, right? This 1, 2, 3, 4, this is negative 4 down here. The range is all real numbers that are above this negative 4. And if you see, it actually includes the negative 4. So all real numbers above this y equals negative 4 line, this dotted line is y equals negative 4. All real numbers above here, so I'll say including negative 4. and then all the other numbers up to positive infinity. And oops, see, there's a good catch right there. Don't put a bracket there. And then this we could say, or y is greater than or equal to -4. Cool? Okay. And so that's a quadratic where the greatest power is 2. Let's look at a cubic where the greatest power is 3. So if you have a function like this, some constant times x to the third plus some constant times x squared plus some constant times x plus another constant by itself. Well, now you have a cubic function. So a, b, c, d are constants. And again, a cannot be 0 because if it was 0, then it would just be a quadratic, right? So let's use a little bit of technology. So the fact that I would probably do a bad job of drawing a cubic function since I can barely draw these quadratics or even a straight line. Okay, so we have a nice tool called Desmos. This is free. You can go online and use it yourself. It's very useful and cool. We will probably use it more in this series on Pre-Calc, but right now I'm just going to use it for something very easy that I just don't want to draw, right? It makes this sort of S curve. How can I? There we go. That's what I want to do. Okay, so there's 1. So x to the third is this cubic function. F of x equals a constant 1 times x to the third plus 0 times x squared plus 0 times x plus 0. Okay, this is all allowed just as long as a is not 0. So our cubic function f of x equals x to the third, is something like this. Like I said, I knew I wasn't gonna be able to draw that very well, so we have it here. Let's look at the domain and range of this thing. So the domain, this goes off to negative infinity in the y direction. And very gradually, it's kind of hard to tell, but it goes off to negative infinity in the x direction as well. You can see it continues to grow. And then up here, it's symmetric over the origin, so it also goes to positive infinity in the y direction, but it's growing in the x direction, as you can see. So it also continues in the x direction to positive infinity. So the domain and range for x cubed, our cubic function, is going to be all real numbers as well. Cool? Cool. Let's look quickly at some other functions on Desmos. It's very handy. There's square root of x, which looks like this. The square root function has this form. F of x equals square root of x plus some value plus k. Okay. These are, again, just constants. H and k are constants. And this specific square root function is what I put on Desmos, right? If we change it to be square root of x plus 3 plus 10, you'll see that this is just a vertical shift of 10, meaning the function that we originally had is shifted up 10 in the y, and then this plus 3, as I've discussed in previous videos, when you add 3 to the input or the x, it's going to shift to the left 3. And if you subtract 3 from the input x, it's going to shift to the right 3. So this is a very useful tool for just familiarizing yourself with different functions. You can just type in any function you've heard of or thought of, and it will instantly be graphed here on Desmos. And then you can see you can manipulate it in certain ways. The square root of x minus 1 looks like this. It's that basic square root function, but shifted to the right one. And let's see, with my example, let's see, what is the domain of the basic square root of x function? Well, let's see, so there doesn't seem to be any x's over here, right? And then I can assume that it's going to go to infinity in the positive x direction. So that allows me to say the domain will be 0, including 0, to positive infinity, okay? And the range, same idea, just by inspection. It's not going to have any y's over here that are less than 0. All the y's are going to be up here. And the graph just continues to rise, going in the y direction positively. So we'll say it goes to positive infinity. So range is 0 to positive infinity. Okay, and the last common function that you may see, absolute value function. This says that when you put an x in, the y that you get out is going to be the positive value, the positive version of that negative number, also known as the magnitude. So if you have -1, it outputs 1. If you input -2, it outputs 2. If you input -7, it outputs +7. The way that one's shaped, it looks like this, right? Straight lines coming from here. Let's see, let's make it accurate. Why not? Okay. It should make sense why the function is shaped like that when you graph it. Right? Because if you come here to x equals 1, then the y equals 1. If you come here to x equals -1, then the y equals 1. And so, once again, the domain is all real numbers. It goes to negative infinity, goes to positive infinity, and the x. So domain, the x is equal to all real numbers. The range, well, there's nothing down here. So the range is all this positive stuff. Again, it makes sense if the range is all positive numbers, then this would add up because only positive numbers come out when you put negative numbers in. And the way to write that is range y is greater than or equal to 0. Or you can say y equals 0 to positive infinity. All right, and so those are some functions that you should be familiar with eventually. All right, so in this lecture, we learned that what a function is, how to use function notation, how to find the domain and range, how to use a vertical line test. We got introduced to basic function types like linear, quadratic, cubic, square root, absolute value, and there's many types of functions. Like I said, there's the sine function, there's all sorts of trig functions, and yeah, this is just the basics, the fundamental, the foundation for all your future endeavors in pre-calculus, calculus, everywhere. This is the foundation of doing real upper level big kid math. So review your notes, go over it and try drawing some of these things, writing this stuff down, try to draw a function on a grid and determine what the domain and range of that function are. Do as I did and start with some x of your function and make a plot like this, a table of x's and y's, and take some inputs, put them in, and then some outputs, see what output comes out, and then that will give you the points you need to draw the function. And you can mess around on Desmos. That will just quickly give you a visual of any given function that you might be interested in. Yep, so I will see you in the next video. Thanks for your time.